In your previous class, we have discussed about Cisco securities being started, how to control the network users traffic by writing some policies, by writing some rules, like a ACL rules. Access control list is a group of commands to control the flow of traffic from one network to another network. And ACL can examine, router will examine each and every packet, whether to drop it or forward it based upon the conditions what we have specified in the router. The ACL will provide layer 3 and layer 4 security. Means with IPv4, IPv6 and TCP, UDP services we can be controlled. And we clearly discussed about ACL terminology, like what is deny, what we can deny, what is permit, what we can be permit, a single host traffic we can, and whole network traffic and the subnet traffic and service traffic also. And we have identify which device is host device, which device is destination device, and we should know where the traffic is in, where the traffic is out. Inbound traffic, outbound traffic. The ACL working, like your ACL works in the sequence order from top to bottom. If match has been found, it does not check further rules. If there is no permit statement, it'll deny all the traffic. So there should be at least one permit statement. And ACL types, standard ACL, extended ACL, a name ACL, numbered ACL. In standard ACL, either we can deny all services, either we can permit all services. Selected services can be denied, selected services can be permitted in extended ACL. So these things we have to see. And today, I'll continue with the scenario is, so this is your router which you're using for office, router LAN interface. And WAN interface. Where your LAN interface has been connected, router LAN port is connected to which device? LAN port is connected to switch, right? Yeah. And switch to end user devices. And what is the fundamental rule? Router LAN interface IP, LAN uses IP address should be in the same subnet, same network. Example 10.0.0.1, 10.2, 10.3, 10.4. All right. Now your WAN ports, serial ports are connected to service provider, ISP. And ISP is connected to internet. Right, guys? On internet, some public networks are connected. Like any public servers, it's gmail.com, say yahoo.com, sb.com, fb.com. Yeah. So yesterday, what we have discussed? What is the topic? Last topic we have discussed yesterday? ACL, like standard extended ACL we have discussed, right? Yeah. Right now, in this scenario, we contact to ISP for public IP and ISP will provide public IP. So that public IP we used to assign for your WAN ports. Say 16.1.1.1. Now tell me routing table updates if LAN port is up and even your WAN interface is also up. Now please tell me the routing table update.
.00 is .00, 16.1 or directly connected.
Yeah, 10.0.0.0 is directly connected to fast Ethernet. And 16.0.0 is also directly connected to serial port. All right. Now scenario is 10.2 user want to communicate with 10.4. So source is 10.2, destination is 10.4. Now source IP, destination IP, both are in same network or different network?
Same.
They're in same network. Now this packet will come to switch and switch will broadcast, will get the reply, and they can communicate. So internally they can communicating like this. It's okay. Now the scenario is 10.2 user want to communicate with a Gmail server. So source IP is 10.2. Then what is the destination IP address?
Gmail address.
Destination IP is?
Gmail.
Yeah, my question is, what is destination IP address? Yeah, our destination is Gmail, okay. But do you know the destination means Gmail IP address? We don't know. Like if you know Gmail IP address, example, Gmail IP address is a like something 120.1.1.1. So now what is the destination IP? Destination IP is a 121.1.1. Now your packet is being generated. Now source IP, destination IP, both are in the same network or different network? Different network. So packet come to router. Now what router will do? Router will check routing table if destination is available or not. If destination is there, then forward it. If destination IP is not available, then what router will do? Stop the traffic simply. So means now in routing table, you have only two directly connect networks. So 120.1.1 IP address is not there in routing table, then what router will do? Dropping your traffic. Then how we can reach Gmail? Like how we can reach Yahoo? How we can reach the Facebook? So this Gmail IP we need to be updated in your routing table, like 120.1.1.1. So I have updated. Now you can reach to Gmail. All right. Yeah. Can you please check audio? Is it clear for everyone?
Sir, yes.
Yes, yes, sir.
Okay, okay. Anil, can you please check from your side?
Kind of breaking from your side, so I don't know what's wrong with that. Maybe I will disconnect and rejoin.
Yeah, better to do it. From my side also, I'll check it. All right, let me know, all of you, if my voice is breaking or any something. Okay? I think it's clear now, right? For everyone?
Yes, Balu,
Yeah.
it is clear.
Okay.
Clear.
Okay. Now, destination IP we have updated in routing table about 120.network. Then all my LAN users can reach Gmail network. Now, how users can reach Yahoo network? So first thing is we have to know your Yahoo server IP address, and after that, that information have to be updated in your routing table. Two things you have to do here. One thing is what? You should know Yahoo IP address. Then that Yahoo IP address need to update in your routing table. Again, Facebook, how to reach the facebook.com. So first thing is what? You should know your Facebook IP address, and again you have to be added in the routing table. Like in internet, how many websites is there? Number of millions of websites. So we don't know IP address of the websites. The entire internet is unknown destination. Like we don't know IP address of the destinations. So if we don't know IP address, then how we can reach internet? So how router will forward the traffic to unknown destinations? See, router functions we know clearly. What router will do? What are the traffic will come to router? We'll check the routing table. If information is available, then forward it. The information can be updated with the static routing. That information can be updated with the dynamic routing is secondary point. The primary point is what? Router will look into routing table. If destination, how to reach the destination information is there, then can forward it. If it's not there, drop it. So we know clearly about the router function, right? The same scenario here. Now destinations, we don't know unknown destinations. Even if you know, is all the millions of IP addresses need to be updated your routing table. Hello, are you getting my point here?
Yes, sir.
Yeah. So then how generally we are reaching internet? Even we are using very small device in your homes for internet, like your Wi-Fi routers. So through Wi-Fi router is forwarding traffic to internet. So how it be functioning? How it be forwarding? Is it maintaining all the websites IP addresses? Is it possible? No. But still we are reaching internet. So how it's possible? When your home Wi-Fi router is not configured with the static routing, is not configured with your RIP or OSP or any other protocols. But how your traffic is being forwarding to internet? Ten dot two dot 1.9, 172.16.1.1, 192.168.2.1. So what will be the network ID of first IP address? Network ID 10.0.0.0. Second IP network ID. Yes, please. This IP address network ID
16.00.
16.0.0. The last one network ID
68.2.0.
So 192.168.2.0 indicates how many IP addresses? 254 means 2.1, 2.2, 2.3, 2.4 up to 2.254. These all IPs comes under 2.0, right? Yeah. So 172.16.0.0 indicates how many IP addresses? 172.16.0.1, 0.2, 0.3, 1.1, 1.2, like. So this network indicates how many IP addresses?
63,000 something.
Yeah,
6,000.
65,534 IP addresses, right?
Hmm.
So similarly, 10.0.0 indicates how many IP addresses? 10.1, 10.2, 10.3, like up to 10.55, 255, 255. Like these IP addresses, how many IP addresses indicates? The 16 million, 16,777, 214
7
IP addresses,
million.
right? Yeah.
Yeah.
So these all are class A network, class B network, class C network, but entire IPv4, 4.3 billion IP addresses will be identified by a global ID which is 0.0.0. So this global ID indicates how many IP addresses? How many IP addresses?
Yeah, 4.3 billion or something, no?
4.3 billion IP addresses. So what I'm doing is in my routing table, like I don't know Gmail IP, I don't know Yahoo IP, Facebook IP, then just simply I'm updating my routing table is 0.0.0.0. Global ID have been updated. Only one line command. Just this global ID. Now my R1 maintains how many IP addresses?
4.3 billion.
4.3 billion IP addresses is my router maintains. So now Gmail comes under 4.3 billion IP address. Yahoo comes under this. Facebook comes under this. Like any destination comes under 4.3 billion. Now what your router will do? Now router will drop the traffic? No. Like your user request is source IP is 10.2 and destination IP can be any address. It can be any address. when packet is coming to router, what router will do? Will check the routing table. Yes, I have 4.3 billion IP addresses. I can reach to any destination now. Now it's just simply forward to ISP. So it's not dropping your traffic. So this type of routing we call default routing. So every internet router is being configured with default routing. So LAN uses traffic to reach internet. Default routing is must be configured. So default routing is to configure generally to access internet where your destination is unknown.
But in this case, Balu, we have even the private network as well, right?
Yeah.
Even that will come. So that will bypass even that, or how is it going to work?
Every even your destination is a private network, your destination is a public network, any network, your the simple logic is here, your router is not dropping the traffic. That's it.
Okay.
You just forward to where ISP. Now ISP is maintain the DNS servers. ISP is the maintain what DNS servers. In DNS server, your request is a Yahoo. So DNS will provide Yahoo IP address. Your destination is a zoom.com. You will provide the zoom.com IP address. Your destination is a WebEx. Will provide the WebEx IP address. So based upon your websites, DNS will provide IP address. So that's happening in your ISP site. Then what is our router job? Your destination can be any destination. Don't drop your traffic. Forward to ISP. That can be private network and public network, any network. So this routing we call default routing. So every internet router, even your home routers also is being pre-configured with default routing. So because of the default routing, our traffic is not dropping and our traffic reaching to ISP to internet. So if you are using a Cisco routers in your homes, or if you are using a Cisco routers in your offices for internet, in that default routing must be configured, then only traffic can be reached to internet. So if we configure OSPF routing, and OSPF routers only can reach. If we configure RIP routers only we can reach. But we have to reach to any destination, like millions of websites in internet. How we can reach it? Default routing. Okay. So how can configure default routing is like default route is identified by all zeros in the both network and subnet mask portion 00000. Any network, any subnet mask. So it is generally configured for accessing internet where destination is unknown, and it is least preferred route in the routing table. In routing table, if we configure default routing, it is going to store in the last line of the routing table. I'll show you the practical how to configure default route. Yeah, we have three directly connected networks. The simply can write IP route 0.0.0, 0.0.0, exit point serial, whatever your ISP towards is connected, serial 0/0. That's it. That's the default routing command. Now if we check show IP route, yes, default routing is added, and default routing code is S star, S asterisk. Only S is a static, S with a star is default routing. Yeah. So clear guys? Any doubts about default routing?
Balu here, I have one doubt.
Yeah.
So now in the router one, so if I want to restrict some sites, for example, some unauthorized websites, so during
Yeah.
that time, whether we need to go ACL based on the IP address or based on the port?
Yeah. ACL can examine based upon the IP address only, or ACL can control the traffic based upon the services only, like HTTP service we can control and FTP service we can control. The specific websites you want to be controlled, then you need to be firewall. The rules need to be right in the firewall, not in the router. Router can control the traffic with a basic level, like whereas IP address based and port number based, I mean services based. But exactly websites we can be denied. Websites we can be denied in the firewall. We require the firewall to use in our network.
Okay.
Yeah. So they're about default routing. So the main point is what must be configured in routers to reach internet. Default routing must be configured. Every internet router must be configured default routing. Okay. Yes. Next point is same scenario. LAN. LAN interface connected to switch. WAN port is connected to ISP. ISP to internet. Serial port, we have assigned the public IP, which is 16.1.1.1. How LAN users can reach a public network, internet. So internet is public network. Within a LAN is what? It's private network. Now how LAN users can reach internet, what must be configured in router, guys? Default routing. Have configured default routing and the code is S star. Default routing is configured. Now traffic is going where your exit point, which is serial 00. Okay, so your router is not dropping the traffic, now it's forwarding. But again, one more point is within a LAN, we have to use private IP address or public IP address? Private. So in a private network, you have to use private IP address. Internet will works with what? Public networks in public IP address, right? Now, first user is trying to reach one of the website in internet. What is source IP? Source IP is private network. What is destination? Public network. So this user is trying to reach public network with which IP address? Private IP address, right? So this logic, your router is not going to accept your traffic actually. Again, your router is going to drop your traffic. Why? Because of 10.2 user is reaching internet. Means private user, by using private IP, you're trying to reach public IP, public network. So how it can be allowed? Your router is dropping again. You want to reach public network, use public IP. So in this class, in this logic here, if you use private IP in the LAN, internally within a LAN they can communicate, but can we reach public network with private IP address? No. The route is going to drop in the traffic because of you're using private IP. With private IP, you're reaching public IP. It's not possible, no? Then what we need to do? So to reach public network, we have to use public IP. So I have used public IP in the LAN 90.2. 90.2. Now source is public, destination is also public. Now can you reach internet? Yes, we can reach internet. I'm reaching internet is okay. Now my computer is a, which is 10.2, 90.2 computer is a public computer, private computer now. So you have assigned public IP address. So means your PC is now public computer, right? Now all public users can come to your public network. So within your LAN is not secured now. So this is the logic here. If you use private IP, your network is secured, but you're not able to reach internet. If you use public IP, you can reach internet, but your network is not secured.
In this case, VPN will help.
Yeah,
VPN.
VPN. No.
Balu, so confused actually, sorry. Because once this private IP or public IP is there, so router is having this default router, it forward, na? So how router will know it is private or public?
Router is ready to forward any traffic because of default routing is there. Default routing is only to forward the traffic. But again, the logic is what? It's a private and public. So you reaching public network with private IP. Okay, there's a problem again.
He is asking that how the router know whether it's forwarding from private to public.
So
How the router
traffic is coming from where? LAN interface.
knows. Okay.
LAN interface is what? This is completely private network. And the WAN port is what? Public network.
No, my question is, Balu, is router will identify public and private IPs also?
Yes, of course it has to identify it. I'll tell you how to identify it.
Yeah.
Basically, now if we check your computer IP address, even my computer IP is 192.168.0.4. So my PC I'm using private IP, public IP. Private.
Private IP.
But still I'm getting internet connected to WebEx server. The same thing happening in every network, every users also, even your mobile phone and your laptop is a private IP, but you're reaching public IP. So how it's possible means we have to use one mechanism to translate private traffic to public and public to private. So that translation is we call the NAT, network address translation. So here NAT must be configured in your router. So if we configure NAT, now NAT is going to taking care about your private traffic to reach a public network. What NAT will do is going to translate. Your IP is safe, your network is secured, you use private IP only in the LAN. Then how we can reach means NAT will take care about it. So what NAT is doing is, so your traffic is coming from private IP, that source is going to change as a public and will forward the traffic. And when public service is giving reply back, again it's translated to private traffic. So NAT is a process of changing one IP into another IP, like private IP to public and public to private, vice versa, like this actually. So every internet router must be configured. The protocols are what? Configuration is what? Default routing must be configured and NATing must be configured. If you configure only default route, no internet access. If you configure only NAT, no, then also no internet access. Default routing, NAT, both must be configured in every internet routers.
NAT is a virtual IP, right? It is not a physical IP.
No, it is just a process. It's not a
But
virtual or
physical,
physical.
but this physical IP addresses will
IP
not
address,
be
yeah.
the translation that we are doing.
Hmm.
Are those IP addresses which are physically not available in that network, right? In the NAT?
Available IPs only
We are
translating.
mapping them. We are mapping them to some other numbers, right? IP addresses, right?
No, whatever you have the public IP in your WAN port, this is going to manipulate actually. You have public IP, right? So
Yeah.
example, 10.2 user is reaching internet. So what is
Yeah.
the source IP? Source IP is 10.2. Destination IP something 120.1.1.1 public IP. Traffic is being generated. Will come to router. What router will do? You're reaching public network with private IP. I'll drop your traffic.
Router will look
Then
in that routing
what
table.
NAT will do? Yeah, what NAT will do? No, you don't drop the traffic. I will take care about to forward it. So what NAT is doing is now it is going to manipulate that source is not 10.2. Now source is 16.1.1.1. Now what is source IP? Public IP. What is destination IP? Public IP. So reaching
Public
internet.
IP. Okay.
Now when it's giving reply back again, your destination means destination reply. Yahoo server reply. You're reaching Yahoo 120.1.1.1. Right? Now source is 120.1.1.1. Destination is means public users, they will not reach to your computer. All public users can reach up to our WAN ports only. So public server's destination is WAN port 16.1.1.1. Now what is source IP? Public. Destination IP? Public. So
Yeah.
when
Okay.
traffic will come to WAN port, now WAN port is doing is going to manipulate again. Now your destination is not 16. Your destination is 10.2. So that will be mapping by NATing will be taken about actually.
Thank you.
Yeah. Sorry, Nishant, your completely voice is breaking actually. No, can't hear you properly. Can you please check it again? Yes. Yeah, what he's asking others, can you hear them?
No, voice is not audible.
No, no.
Oh, he left. Maybe he's rejoining. Right. Can see this NAT. NAT is the process of changing one IP into another. It is used to save precious public IP addresses. What NAT will do? Used to translate private IP address to public IP addresses and vice versa. It provides a security. Means by using private IP only, we are reaching internet. It's secure. Okay. Now we'll see types of NATs. Many types of NAT we have is, the first method is static NAT. So how static NAT works is 10.0.0.2 user. How we can reach internet with 16.1.1.1, and these IPs are fixed. So you know what is NAT, right? It's a process of changing one IP into another IP. Then what is static? So something manually we are defining. So we are configuring whenever 10.2 want to reach internet. So 10.2 user traffic has to be manipulated by map with 16 IP address, 16.1.1 IP address, always. And the both IPs have been fixed. So when 10.2 is reaching internet, traffic will come to router. In router, NAT is configured, which is static NAT is configured. What have configured in the static NAT? 10.2 user traffic. Use source as a 16.1. Then 16.1 is been mapping and reaching the internet. But my question is here, then how 10.0.0.3 user can reach internet? Yes. How 10.0.0.4 user can reach internet? 10.2 16.1.1 IP address is fixed. So 10.2 user always can reach internet with 16 IP address. For what about 10.3? So for 10.3 required one more public IP address will need to be purchased from ISP. Example 17.1.1.1. And this IP is fixed. So even 10.3 user also reaching internet with 17.1.1 always is fixed. Manually we have configured that actually. Okay. Then how 10.4 user can reach internet? The 10.4 again we required one more public IP address need to be purchased from ISP 18.1.1.1 and this IP is fixed. So how exactly static NAT is working is it works with 1:1 ratio, 1-to-1 mapping. If you have 100 private users, then how many public IPs are required? As per static NAT, for 100 private users in the LAN, then how many public IPs are required? 100 public IPs are required, guys. Okay. So each public IP address will be purchased from the ISP. So it's not good. Then we'll go for next method of NAT, which is dynamic NAT. So how dynamic NAT works? Even dynamic NAT also works same like a static NAT, says 1:1 ratio. Means you have 100 private users, then 100 public IPs are required. Even dynamic NAT also. Then what is the difference between static NAT and dynamic NAT? In static NAT, which we configured manually, so-and-so private user traffic has to be reached, so-and-so public IP address, and IPs are being fixed always. But in dynamic NAT, you know, 10.2 user can use any one public IP from this pool of public IP addresses. 10.2 user can use 16, or 10.2 user can use 17, 10.2 user can use 18. Left pool of private IP address, pool of public IP address, any one IP can use any one public IP can reach internet. So 10.2 sometimes use 16, sometimes use 17, sometimes use 18. But in static NAT, that manually we have configured 10.2 user always have to reach internet with 16 and fixed. Both IPs are fixed. And manually again we have configured, we are mapping 10.3. You reach internet with 17 IPs are fixed. The static NAT. In case of dynamic NAT, so 10.2 we are not defining anything how to reach internet, which IP address. So 10.2 user can use automatically out of 3 public IP address, it can use any one, automatic mapping. That is only the difference between static NAT and dynamic NAT. But in static NAT, 1:1. Dynamic NAT, 1:1 ratio. Like 100 private users, 100 public IPs are required. The both. So which is the best, static NAT or dynamic NAT? Which we use in the real time?
Dynamic.
Dynamic.
Why?
No need of
They are not fixed.
can use whatever IP is available to reach the destination.
But you need to be purchase 100 public IP address in dynamic NAT.
Both are same.
But even in static, but
Yeah,
in
for
static,
only for your
the-
company, you have 1,000 users in your company, 1,000 employees. And how many public IPs are required?
1000.
So only for your company, 1,000 public IPs means then how globally we can survive?
Yes, static, ma'am.
Even we cannot purchase the thousands of IP address. Each public IP is a high expensive. Even if you are ready to pay, service providers are not ready to pay actually. We don't have a public IP addresses much. So both are failed actually. Then one more type of NAT method is there.
That
Exactly. Which we called
port address
port
translation.
address translation. PAT. So how PAT works? Now 10.2 user can reach internet with 16. 10.2, 10.3, 10.4, 10.5, 10.6, like many private users can reach internet with only one public IP address. Within your private network, within your LAN, have a 3 users or 30 users or 300 or 3,000. Like many private users, traffic can reach internet with only one public IP address of PAT, port address translation. So this PAT is also one of the type of NAT. Okay, so in real time we use what? PAT, no dynamic NAT, and some scenarios we use static NAT also. Mostly we use what? PAT. So every internet router is being configured with default routing and NAT method, which is PAT. So many private users means how many? Like 60,000 private users can reach internet with only one public IP address. So when NATing and subnetting is being developed, because of NATing and subnetting based upon these technologies, still we can survive with IPv4. So till today, we are getting internet with IPv4 means because of the two options, which is NATing and subnetting. So subnetting is minimize the IP addresses wastage. We'll take one public IP and we'll customize it. On internet, reaching internet, we don't require the multiple public IP address. Only one public IP is enough to all 60,000 private users. So in your company, you have 1,000 users or 2,000 users or 5,000, 10,000 users in your company. Then how many public IPs are required to internet for all 10,000 users? One is enough. Okay. So types of NAT is static, one-to-one mapping, and PAT, many-to-one mapping. So in real time, we use this type of NATs, static NAT and PAT, mostly PAT and some scenarios static NAT. So where we use static NAT? We'll see that. Static NAT, one private IP address is mapped to one public IP address, 1:1 ratio. Generally, the static NAT used for hosting public servers.
Voice communication also.
Voice communication, yeah, that is the one server, voice server, and we use it actually. Internet to server. If you are hosting any servers in your office, you have any, like example, the best example, in my office I have a server, which is Zoom server is there. It is my office LAN. Here I have the Zoom technology server. Is in my LAN, right? The LAN employees also connected. We are connected to here. So this Zoom server, we have been, like all the information is available, like your batch timings and the course details and everything will be available in the Zoom server. So how the users can access this server? Means you are the users, you are the students, like how we can access it? You are not coming to my office, right? You are somewhere. You are in the internet. You are in internet in the different various destinations. So what we are doing is I'm using a router and I connected to ISP to internet. So these Zoom public server, this server I want to host in internet, means public users, the students want to use it. So server to internet, I mean internet to server, use which netting is a static net. So generally configured for inbound traffic. Router LAN port and router WAN port. Example, Mr. Anand, you are where? You are in my office or you are in the internet? Where you are, Mr. Anand now?
Internet.
Internet, okay. Now Mr. Anand is trying to open the Zoom website. And what he's typing is zoom.com. So from your computer, data traffic is being generated now. So source is your PC, destination is my server. So traffic is coming to internet, internet to ISP. ISP to traffic is coming to which interface?
The router interface.
Router which interface?
NAT.
NAT.
Router serial port, right? Means traffic is coming to the interface. Traffic is coming means is inbound. Inbound traffic. So all public users means all the students traffic will come to my office router WAN port. You know, all the students traffic will come to my office router WAN port. Means incoming traffic is inbound. All the traffic is coming to the WAN port. So we have configured static NAT, internet to server. So so public IP come to my server. This is one method, static NAT. But my requirement is my employees, LAN users. Many LAN users want to reach internet. So here, LAN users want to reach internet. LAN to internet we use PAT. Means what? User traffic is generated come to LAN port to WAN port. So WAN port is what? Traffic is going to outside from router. So students traffic is coming to router. My employees traffic is going to out, right? Is outbound traffic. So for inbound traffic, static NAT. For outbound traffic, PAT we used to configure. Okay. Yeah.
Balu, can you, Balu, here, so one more doubt. For example, now one PC, for example, Anand PC is accessing to inbound traffic. Okay, so during that time, it will use one IP. So at the same time, if I am able to use the same Zoom server, so then how this router will give the IP, allot the IP?
Here, WAN is a destination. Means WAN IP 16.1.1. So what are the traffic is coming to 16 dot? It has to be mapping to my Zoom server. Zoom server is private IP 10.0.0.100 have configured. So 16.1 traffic is mapping to 10.0.0.100. Your IPs are different. Your IP can be any IP. Means there are many students is there. They are trying to access. So you are not the source. The traffic is generated. It come to WAN port. From WAN port to LAN. Here is the manipulating 69 network to 10 dot network. Static. 1-to-1 mapping. Okay. It's clear? Hello.
Yeah, Balu.
Yeah, right. So how to configure NAT configuration. See the configuration of NAT. See, this is very important. Static NAT or dynamic NAT or PAT. Any type of NATing you want to configure. Before configuration of NATing, it can be static or dynamic or PAT. The first thing is we need to be define NAT on interfaces. We need to be configure NAT on interface. Example, fast Ethernet is connected to where? Local network, private network. A serial port is connected to where? ISP. But how router knows about that? A fast Ethernet is connected to your private network. And how router knows about your serial port, your WAN port is connected to public network. Because of it has to be mapped, right? So private traffic had to be translated to public and public traffic had to be translated to private. So how routers knows about where the private traffic and where the public traffic? So that's something we need to be defined. How we can define is in for LAN ports, we need to be write the command is IP NAT inside. If we use this command IPNAT inside, then router understand, okay, NAT inside means on this interface, NAT is private network. On fast Ethernet, NAT is private network because of inside means private. And WAN ports, when to be write the command is IPNAT outside. If you write this command on serial port, IPNAT outside, then router will understand, okay, NAT is outside on serial port. So fast Ethernet is a private and serial is a public. It's translating inside traffic to outside traffic to inside traffic. So these commands are mandatory, must be configured for static NAT also, for dynamic NAT also, for PAT also. For any type of NAT, these two commands has to be configured mandatory. Okay. Defining NAT on interfaces. Interface serial 0/0 IP NAT inside or outside?
Outside.
Outside. Interface fast Ethernet 0/0 IP NAT inside or outside?
Inside.
Like this. Like in router 2. IP NAT inside. Serial 0/0 IP NAT outside. This is a common configuration for any type of NAT, static NAT, dynamic NAT, or PAT. Right? Now you can configure static or dynamic or PAT. So how we can configure static NAT? This is static NAT configuration of static NAT. IP NAT inside source static. IP NAT inside source static. Like the private IP. What are the private IP? We had to configure now. IP NAT inside source static, like 10.0.0.2 before the example 16.1.1.1.1, you know. So that's something manually we are mapping 10.2 user how to reach internet with 16.1.1. Generally, this 10.2 is your server, this is your public IP, one-to-one mapping. Like 10.3 user how to reach with 17.10.4, 18. Like need to be configured one-to-one mapping, static NAT. Okay. The next is PAT, port address translation, PAT overloading. Many private IP addresses are mapped to one public IP address, many to one. How many? 60,000 up to. Configured for outbound traffic. Means LAN users are reaching internet. My employees are reaching internet, LAN to internet, like your home to internet, your personal laptops, your personal mobile phones to internet. That is PAT, outbound traffic. Your traffic is going to outside, LAN to internet. Okay, many to one and LAN to internet. The main point is all users can access internet at the same time. What is the point number 3? What do you understand the point number 3? Yes, please. All users can access internet at the same time. What is the point?
Many to one. Many people can access one public IP.
That is the point number 1. Many private IP addresses are mapped to one public IP address. All users means how many users in your network? Every user, right? Means 10.1, 10.2, 10.3, 10.4, 10.5. So all users means the whole network means 10.0.0. Network ID. All use indicates what? Network ID. Can access or cannot access? What is this point? Can access. So can access means is a permit rule or deny rule?
Permit.
So can access means is a permit. Can access internet. Internet means all service or limited services. Internet means
All
what?
are
All services. So along with the PAT, we need to be configured ACL rule for permit network ID for all services. No, we need to write the ACL to permit the network ID for all services. So which type of ACL can permit all services and which type of ACL can deny all services? Standard ACL and extended ACL.
standard.
So here we need to be configure standard ACL in permit rule. Then all services been permitted for under the network ID. So default routing is must. NATing is must. And we need to write ACL rule also on permit rule. Then all LAN users can reach internet at the same time. Okay. Let's see another configuration. 10, 20, 30, all users can reach with only one WAN link, right? So means 1.10 traffic has to come into WAN port, 1.20, 1.30. Many private users traffic is coming to serial port. Now on serial port, we're going to write overloading command. If you write overload command, then only your serial port can take more IP addresses traffic to reach internet, many users traffic. If you don't configure overload, again your WAN port allows only one private traffic to reach internet, similar to static NAT. So that is a PAT overloading mechanism means of writing the overload command, then your serial port will take the many traffic. Okay, that is the point here. So command statement number 1, statement number 2. Both the statements are common, defining the NAT inside outside. So PAT configuration is the last 2 commands. First, create the ACL rule. Access list 10. 10 means standard ACL, permit, a whole network, and subnet wildcard mask. Next, IPNAT source, IPNAT inside source list means ACL number. What is the ACL number 10? Permit. To whom? The whole network. And traffic has to go via which interface? Interface serial 0. What I'm dealing to serial 0? Overload means all the network traffic you forward with one public IP address. Like this. So for static NAT and dynamic NAT, your verification command is show IPNAT translations. In the PAT also, whatever we have configured, inside outside command is a common. Interface, fast Ethernet 0/0, IPNAT inside is already configured now. No need again, I'm just writing the commands. Serial 0/0, IPNAT outside, access list, ACL 10, whole network, 10.0.0.0 network. The rule is what? Permit 10 dot network 0.255.255.255. Now I can write the PAT command, IPNAT inside source list. IPNAT inside source list ACL10 interface on serial 0/0 overload. This is PAT configuration. Okay. Now verification, show IPNAT translations. Here we have inside the global, outside the global means 16.1 reaching internet with 10.2, 7.1 reaching internet with 10.3, like that mapped. Okay. Right. So this is all about default routing and NATing mechanisms. Any doubts?
Palu, one question here.
Yeah,
Hello.
Mahesh, please.
So actually, in my organization, like we use like to book IRCTC. Sometimes, like if one user has already accessed that and they have booked through that, the system will not allow the other user to book from the same IP. So, what kind of is this related to this static NAT only, or suppose
They
you have
offered,
already
no, they
accessed?
have
Yeah.
allowed,
Okay.
they have allowed the use a public IP with
Mhm.
10 numbers only or 5 numbers only. So user 1, user 2, user 3, user 4, user 5 are
Okay.
accessing internet or booking the counter. So they allow
Mhm.
how many users? 5. Now
Okay.
when sixth one is trying to use it, will not accept it actually. But if anyone is being disconnected, again this will be free and you can use it.
Okay.
So at the same time, maximum 5 users can allow the internet access. That's something they have configured actually.
Okay.
So when someone is been disconnected, so other person again allowed.
Okay.
So in your LAN, maybe you have a 10 people or maybe 20 people also.
Mhm.
At
It
a
will allow
time,
only.
5 users, only 5.
Okay.
So
Okay.
he booked and he disconnected. Again, sixth one, again seventh one, like that will be allowed actually. That
Okay.
is been configured there.
Okay. Well,
Yeah.
thanks.
So let me continue with some network services. Almost,
Ba-
yeah,
Balu.
please.
So actually, I used to get the message like this IP was already used to book
Yes,
that. So that is what my question was.
exactly. The same. The dive is already used now.
Okay.
Let's see some network services. It's your router 2, R1, R3. Number of routers are connected in this scenario here. R4, no, R5, R6. Some devices are connected. Think almost so few people are working in the real time now, right? In our meeting, in our participants. Do you have access to login routers in your offices? Anyone?
We do have.
Yeah, Anil. Okay, you have, right?
Yep.
Yeah. So in your team, you only have a limited persons only have the access.
No,
Everyone,
everybody have the access.
everybody, like a junior team and a senior team, right?
Yeah.
Okay.
But we have some restrictions for like contractors and full timers.
Yeah. Why restrictions is there?
Because some of the fabrics, those are so delicate, and most of them are congested, so they don't give like authority to the
Yes.
one fabric, only one fabric. Remaining other fabric is well good to go.
Okay. So security reasons, right?
Yep. Yep.
Yeah, exactly the same thing in junior engineers, or there will be a knock team. operation centers, network operation centers team, and senior administrators, some different roles will be available. What is the job of NOC engineers? The NOC team 24/7, they're actively monitor the customer's traffic. The company which is taking the project of the customer. So that customer's traffic has to be monitored by the NOC team by 24/7. The thing is, they don't have access to the login to routers, customer routers. See, if you log into router, then you can come to know what exactly happening inside the router. Your WAN port is down or your LAN port is down, when it is down, why it is down, what is the problem, triple P, HDLC, or you shut down or whatever, what the protocol neighbor is up, OSP if neighbor is down. So why the link is being failed in a protocol issue? The completely happening inside the router. If you log in, then you can come to know the logs, like show IP interface brief, show IP route. The table we can check it out. We can know. Then how the operation centers monitor the traffic?
SNMP.
Okay, this is point number one. Because of they don't have a privileges to log into, they don't have a credentials to log into router. They don't allow actually. This is point number one. Now point number two, see if any changes in the router. Example, if we configure any OSP of routing, then enable will be formed. Let me quickly configure OSPF. Yeah, we have an OSPF update here. Right. Now, interface serial 0/0, it's down. When your WAN link is down, we got one log message. So on serial, admin lay down, protocol is down. Again, if your link is been active, you got log message, change state to up. So similarly, if serial 0/1 is down, now interface is down. At the same time, neighbor is also down. OSP of neighbor is down. Again, your interface is active, no shutdown. Again, we'll get log message. Interface serial protocol is up, and OSP of neighbor is up. So this all the logs information will be stored inside the router. Whatever the changes happen, your neighbor is been up, neighbor down, serial up, all the logs notifications will be stored inside the router. That memory we call buffer storage. day 1 logs, day 2, day 3, day 4, like is all the logs is storing in the buffer. Say after day 10, what if your buffer is been full? The router buffer memory has been full because of router inside the router is very low memories, right? So once your buffer is full, then what about your day 11 logs?
First in, first out.
First in, first out. Like your day 11 logs has been to store that your day 1 has been override erased. Day 12, day 2 logs, day 13, day like this. So after 3 months, so which logs we can get? The last 10 days only now. So can we get for starting 10 days logs information, like 1 month logs information can we get? No. Like in network audit, network auditing, if someone asking you, like I need a first 10 days logs information, so and so customer link is down. So why that link is down? Someone man wantedly making down or any issues has been happened and when it has been resolved, why linkage is down? That for auditing security reasons, we need a logs information. But we are not getting the logs information here. So there is a problem. So here, two cases. One thing is your NOC team, they don't have a credentials to log into router, but they want to be monitor the traffic. The same time is all the logs if you're storing inside the router, there's a problem with the buffer storage. So to overcome the both issues, in real time, what we'll do means we'll maintain one external server. I'll tell to router, if you have any notifications, any logs, just send to my external server. You don't store inside your router. You just send what? To external server. So your server can be maintain the logs information for 1 month logs, 2 months log, 1 year, 2 years logs also can be maintained external storage. And moreover, there is no processing burden in the router. If you store inside the router, processing burden. So what I'm telling is, if any notifications you send to external server. And what your NOC team will do, so what NOC team is doing is, for the server, they used to connect the very big screens. And they're sitting in the front of the screens. They used to keep monitor for 24/7. So from the screens, they used to monitor what happening inside the customer devices. What happening exactly in customer routers, they can be monitored here actually because of any notifications is sending to server and server to your screens is being connected, your monitor here actually. So this is exactly happening in the NOC team. So this server is syslog, system log servers. So syslog is a protocol that allows a network device to send their system notifications messages across the message collectors, typically used for network management and security auditing. Device can be configured to forward system messages to various destinations. One is a buffer storage, internal memory buffer. One more is external syslog server.
So the syslog server is a proprietary one for Cisco or it is configured?
Open. See the configurations. In router config mode, you just use logging on, logging host, syslog server IP address.
Port number?
No need. This is your syslog server IP address. Yeah, example. I'm connecting one external server here. Let's say this server IP address 10.0.0.123. Now inside the router, we'll do logging on, logging host 10.0.0.123. Like this. That's it. Now, any changes in any modifications, any logs in the router, it would send to this server. To which service syslog. This is syslog. Let me do some modifications. Interface serial 0/1. Let me make it as a shutdown. No shutdown. And we got a log message here. Serial 0/1. Change state to up. Have you seen this? Protocol is up and the OSPF. OSPF neighbor. So on some process 123 neighbor 1.1. Loading to full is done. Like if it is again shut down, like any notifications will get on here actually. So interface is down. The neighbor is down. Is all the logs information will get. Where? To your server, syslog server. Syslog server is connected to your monitors, very big monitors. The team in front line, they used to monitor the screen. Like this. Clear? Next point is in R1, if I check show clock, what is showing the date and time? 1993 March 1st, Monday. So if any OSPF neighbor is active in R1. So for R1, as per R1, when the neighbor is active in 1993 March 1st, OSPF neighbor is active. If R2 is 2021, we are in the 2021. So R1 is in 1993. Problem. So in your live networks, every network device, your PC, your switch, your routers, servers, no firewall, every router should be maintained the same date and time. Even if you have a wrong date and time for your machine, for your PC, can we get internet? Just to change your date and time and you can try to check the internet, we don't get actual internet because of your PC should be synced with the same date and time with internet. So here we have to set the clock. Clock set 09, 9 hours. 40 minutes, 30 seconds. 9 hours, 40 minutes, 30 seconds. 22nd April 2021. Like we can set the clock. Show clock. So exactly Thursday, 22nd April at 9:40. So like we can set the clock, but it's not best practices because of manually if you are setting the clock in all routers, so it is not best practices. The best practice is we can use a centralized source clock, like NTP server required. So if you have a NTP here, for example, this is a NTP server, network time protocol. Now don't set the clock in R1, R2, R3. Like your all networking devices will get automatically date and time from this source, NTP server. Synchronizing. What is the date in NTP server? What is the time in NTP server? With this date and with this time, your router 2 is syncing, router 1 is syncing, router 3, like all networking devices will get the exact date and time from centralized source clock. Automatically they'll get. This is NTP server. What is server IP? Before I have assigned 10.0.0.123, right? Yeah, I'll show the practical. Instead of manually assigning the clock, for router 2, if we check show clock, what is showing the clock here? 1993, right? Again, now NTP server 10.0.0.123. That's it. So simply I have configured NTP server 123. This command I have enabled. I'm not manually assigning the clock. I'm not setting the clock manually. It's just I use this command NTP server 123. Now my router 2 will get sync with this NTP server 123 time. Show clock. What exactly date and time now? Is NTP server. Okay. It's clear about syslog and NTP. So this command need to be executed in all devices in your network. Then the device will get automatically synchronize that clock with this NTP server. Yeah, please. Any doubts? All right, so is all about for today. So we have seen default routing and NATing, NAT pad types, some network services like syslog and NTP. So tomorrow we'll continue with some DHCP and router redundancy protocols. Thank you. Have a nice day to all.
Balu, I have a question.
Yeah, please.
So we do have a SolarWinds to monitor and collect the logs, right? So like what is the difference between this one and that one?
Yeah, there are so many applications in SolarWinds, WhatsApp, Tivoli, and IBM, WhatsApp Gold, IBM Tivoli, SNMP, and PRTG, MRTG. There are so many that the SolarWinds, the backend, the protocol is syslog will be, and SNMP has been working. SNMP is working actually. That is
So
only
the
application.
application will configure the routers?
Yes, the application has been configured in router. So we'll tell to router, you send the
And the logs to the
logs to
SolarWinds?
SolarWinds. Yes.
Oh, okay. Okay, gotcha.
Yeah, here this is your server. In this server, you can use SolarWinds, you can use PRTG, you can use IBM Tivoli. Like there are so many monitoring softwares, tools is available.
Yeah.
Whatever the tool you're using for your organization, you tell to router. You send to SolarWinds, you send to WhatsApp, you send to like whatever.
Okay.
Yeah.
Yeah, gotcha. Thank you.
Yeah. All right, guys. Thanks once again. Have a nice day. Meet you tomorrow.